Welcome everyone to a video on order of operations. The goal of this video is to learn how to evaluate numerical expressions by using the order of operations, how to evaluate algebraic expressions by using the order of operations, and how to use a formula in the order of operations to solve real-life problems. Let's start with the definitions. So what exactly are the order of operations? Well, you might have seen these already. When we simplify a mathematical expression, we perform what is known operations in the following order so that we all get the same answer. We do parentheses and any other grouping symbols first. Then we do exponents or powers. Then we multiply and divide, and then add or subtract. Now you have to be careful with these last two. A mistake that some people tend to make is that they think that multiplication is done before division, but if both of these are in an expression, we do multiplication or division depending which one is first from left to right. And also for addition and subtraction, we do whichever one is first from left to right. Now, like I said, you might be familiar with the order of operations, but you might know it as PEMDAS or the Please Excuse My Dear Aunt Sally. So let's go do an example and see if we can actually follow this order to evaluate a numerical expression. So this is a numerical expression because we only have numbers. Let me get a pen. So they're asking us to simplify this expression. So we have parentheses, exponents, multiplication or division from left to right, and then addition and subtraction from left to right. So let's see. We have two pairs of grouping symbols here. We have the square brackets in the parentheses. Whenever you have more than one set of grouping symbols, we start with the innermost. So we are going to do these first. So then 4 minus 2 will make that a 2. So we're going to bring the 5 plus 2 to the third plus 3, square bracket, 6 minus 3. And when you have a number outside of parentheses, that means multiplication. I'm going to drop the parentheses and put the little dot for multiplication and then bring down what we simplified. 4 minus 2 will be 2. Don't forget the square bracket. Continuing on, since we still have a grouping symbol, we're going to do this one first. I have subtraction and multiplication. Because multiplication comes before subtraction, I am going to do the multiplication here first. So this is 5 plus 2 to the third plus 3, square bracket, 6 minus 6. Because that is a result of 3 times 2. We still haven't fully simplified everything inside this square bracket. So we're going to continue to do this. So we're going to do 6 minus 6. And then that result, since this square bracket has a 3, that result is going to get multiplied by 3. Well, 6 minus 6 is 0. So we have 5 plus 2 to the third plus 3. And now I can drop the square brackets because there won't be anything left and change it into multiplication. At this point, we're going to notice that we don't have any more grouping symbols. So then we are done with parentheses. We are left with 2 additions, a multiplication, and an exponent. Because of the order, we're going to do the exponent first. So let's do it on the side. 2 to the third, remember that is 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. So we're going to replace this 2 to the third power with an 8. 5 plus 8 plus 3 times 0. Now you might be asking, can we have done the exponent from the beginning and the parentheses at the same time because they are located in different terms? Yes, you can. You can definitely, as you get better and better at these, you might be able to do 2 steps, 3 steps at a time. But for now, we're gonna do every step in order. Since there are no more exponents, we are done with the exponents, leaving us with only addition and multiplication. So multiplication comes before addition. So we're going to multiply 3 times 0. And we all know that 3 times 0 is 0. So we're left with 5 plus 8 plus 0. Last step, we no longer have multiplication or division, so the only thing left to do is to add or subtract. In this case, we only have addition, so we just have to add 5 plus 8 plus 0, giving us an answer of 13. Almost painless. So in this example, we evaluated a numerical expression. Now we're going to evaluate an algebraic expression. Now this turns from numerical to algebraic because in a numerical expression, we only have numbers. And in an algebraic expression, we end up with some variables. For example, on this one, we have x's, y's, and z's. And they're asking us to evaluate this expression if x is 4, y is 5, and the z is 3. That means that we are going to replace the x with a 4, the y with a 5, and the z with a 3. Let's do that. So we bring the 3. Every time you replace a variable with a number, you're going to place a parentheses. Now, is a parentheses always necessary? No. But if we learn to do this by always placing a parentheses, it's going to save us a few headaches along the line later when we start working with negative numbers. So here we go, a parentheses 2 times 5 plus 3 to the third power, and then a parentheses. But you know what? Because I don't want to confuse these parentheses with the outer ones, I am going to change these outer ones into brackets so that I know which ones are the outer grouping symbols and which are the innermost. You don't have to, but for me, visually, it makes sure that I don't confuse these, the inner ones, when we replace the variable with the parentheses that was already in the expression. All right, don't forget, please excuse my dear and Sally, parentheses, exponents, multiply or divide, add or subtract. So on this one, since we already did example 1, I want to see if we can do more than one step, okay? We are able to do more than one step when the steps are located in different terms. So for example, this is one term, here is another term, and here is another term. So we can do one step from each of the different terms without affecting the result. So on this one, this first term, I'm going to take care of the exponent. So this becomes 3 times 16. For this term, we are going to multiply the 2 times 5. And for the last term, I'm going to do that exponent. Remember, 3 to the third power means 3 times 3 times 3. This is 9 times 3, and this is 27. So this will be a 27. All right. So we took care of more than one operation at the same time. We still have 3 different terms. We have this 3 plus 16, and then we have these 2 inside of the grouping symbol or parentheses. So I can take care of this grouping symbol because these are different terms from the first one, and I can also take care of the multiplication at the same time since this is a different term from this one. So then 3 times 16 will be a 48. And when we add the 10 plus the 27, that will be 37. And we can drop the symbols, the parentheses, the square brackets, because there's no more operations to worry about. And now all we have is the addition of 48 plus 37, and the answer is 85. So this is an example of evaluating algebraic expressions using PEMDAS. We are now going to try solving real-life problems. But let's start with a few definitions. So, an equation is a mathematical statement indicating that two expressions are equal. The expressions can be either numerical or algebraic. So an example of an equation is a formula. A formula is an equation expressing a relationship between constants, remember those are numbers, and variable quantities. Remember, those are letters. So let's try an example here to fully understand what all of these definitions are saying. A right circular cylinder, here's an example of that, with a radius r and a height h has a surface area S in square units given by this formula. Let me write it down over here so we can take it out of all of these words. So S equals 2 pi r parentheses r plus h. Here it is. This formula is an equation because you have two expressions, the left one and the right one, and you have an equal sign between them. If there's not an equal sign, then it's not an equation, it's just an expression. They're asking us to find the surface area. They're asking us to find S, this is what we need to find, of the cylinder that has a radius of 6 inches and a height of 9 inches. And they want us to leave it in terms of pi. I'll tell you what that means in a second. So first, just like we did before, we're going to replace the r with the 6 inches and the h with a 9. So the s will remain because that's what we're looking for. We do 2. They say to leave it in terms of pi. That means that we're not going to touch pi. We're just going to continue to write the pi symbol. Some of you might know that pi is equal to 3.14. And if they wanted us to replace it, they would have told us. But since they want us to leave it in terms of pi, they don't want for us to replace it with 3.14. Let's do the r here. So the r will be 6. And then I'm going to do it again. I'm going to change this into square bracket so I can replace the r with a 6 and I don't confuse the parentheses, and the h with the 9. So now we need to simplify this because this doesn't look very appealing. There's too many parentheses and too many square brackets and too many pluses and all of that. So we're going to simplify them using the order of operations. We're going to start with the parentheses right here, the grouping symbol, and we're going to add 6 plus 9. So then this is equal to 2 pi times 6, and then 6 plus 9 will be 15. But since there is no symbol right here outside, it means that they want us to multiply this 6 or this value with whatever this is going to give us. So 6 plus 9 will be 15. Again, they want us to leave this in terms of pi. So all of these are being multiplied. So I'm going to leave the pi alone and I'm going to multiply the 2 times the 6 times the 15. So 2 times 6 times 15, that's actually 180. And then we're going to leave it in terms of pi. That means that we're not replacing pi with anything. We're just going to bring it down. So the surface area of this cylinder is 180 pi. So now that we went over all of these examples, it's your turn to see if we understood everything that was in this video. Thank you so much for watching, and I'll see you in the next one.